Chapter 3.4 is dividing rational numbers. And we know that multiplication and division are kind of opposites of each other in math. Well, we're going to work these, keeping that in mind, because a division problem is really a fraction, right? But if you have 1/2 over 1/10, I don't know of anybody that really wants to try to work that problem, right? You can't just look at this and just say, oh, the answer is this. Dividing fractions, it's a whole kind of, I don't know, bigger mess than what we want to mess with. So some mathematician along the way, right, way smarter than me, came up with a way to do it that makes it a whole lot easier to do, but still works out with the right answer. So that's what we are going to do today. To be able to understand how we do this, we need to know what it's either called a reciprocal, or I think your notes also call it an inverse, okay? So either a reciprocal or an inverse. It doesn't matter which way you call it, but if you have a fraction, okay, go ahead and put this in your notes. If you have a fraction of 2/3, okay, and you're asked to write the reciprocal or the inverse, all you do is flip it over. That's it. Okay, that's as hard as it gets as far as the inverse. Okay, what if I have a number like this and I'm asked to write the inverse? Well, the inverse is flipping the fraction. Damien? Yeah, first you gotta make this a fraction, right? Now you can flip it, because you can't flip it unless it's a fraction. And likewise, if you have one like this and you're asked to write the inverse, it's really 16 over 1, but we usually clean it up a little bit and just write 16. Okay. Now, if it's a mixed number and you're asked to write the inverse, you cannot do the inverse with it mixed. So before you can do the inverse, you have to turn it into an improper, then flip it. Okay, so 3 times 2 is 6, plus 2 is 8. Now that it is improper, now we can flip it. Okay, so always turn mixed into impropers and then flip them. Okay, if it starts out a negative, that doesn't hurt anything. Okay, first turn it into a improper. So 5 times 3 is 15. Plus 4 is 19 over 5, and then flip it, and it's -5 over 19. So the inverse, right, or the reciprocal doesn't change the sign at all. The sign's going to stay with it. It just flips the fraction. Okay? All right. So with that in mind, the way that you solve dividing fractions is, yes. The way you solve dividing fractions is turning it into a problem that we do know how to do, which is turning it into a multiplication problem. The first fraction stays the same. We're turning this into a multiplication problem, so it's 1/2 times instead of 1/2 divided by, and then we take the reciprocal of the second term. So we flip it over, and now it looks just like last week's. Okay, and last week we cross-reduced, so 2 and 10 have a 2 in common, so 2 reduces to a 1, 10 reduces to a 5, and when we multiply across the top, we get 5, multiply across the bottom, we get 1, so clean it up as just a 5, and then as a last second double check, look back at your original, positive and positive, so your answer should be positive. If you can get in the habit of doing that last little, I mean, it takes you a split second just to glance back and think positive, positive, my answer should be positive, because when you start changing mix and then flipping them, it's really easy along the way to forget where your negatives went in. So it's really a good habit just to get into it the very last second before you put a circle around your final answer. Just flip your eyes back for a second to your very original problem and think positive, positive stays positive. Okay, it'll kind of help you not miss signs. All right. So if we have one like this, okay, number 4. Okay, the first step is to rewrite it. So with all of the division problems, there's always going to be work to show because you always have to flip that second fraction. So with multiplication, the easier ones, remember I said there's really no work to show. With division, there is always something to show because you've got to keep the first, change it to a multiplication, and then flip the second. Now notice it's a negative, and those parentheses are there just to kind of highlight that it's a negative and that you don't lose the negative and the division sign together. So we're going to keep that there, but we just flip it over, put the 10 on top, the 3 on bottom. It still stays a negative. And now we're ready to work it like last week where we cross reduce. Everything's here is divisible by 10. So this becomes a -1 and this becomes a 2. Can't cross reduce the other way because 17 and 3 don't have anything in common. So 17 times -1 is -17. 2 times 3 is 6. And again, if you had forgotten to put the negative up there with the 1, okay, and you got 17 times 1 is 17, taking that last second look back to say a positive times a negative, my answer has to be a negative, it'll help save you. Blake?
So do we have to reduce it? Or?
Yes. You mean turn it back into a mix? Oh, what do the instructions say? Write in simplest form. I'd say I'd probably take it either way because it's not really specific. Okay. I don't know. I'd have to go back and look at the verbiage that it uses in the key to see if simplest form. Let me look and see. That's probably, let me look and see what they consider to be simplest form. This is 3, 4, right? Dividing rational numbers. Yeah, it looks like they turn it back into a mixed. So they must consider simplest form to be mixed. And the reason I want to make sure that I use the right verbiage is because when you get to iLearn, if it says the simplest form, I want to make sure that we're kind of on the same page as iLearn as far as what is considered simplest. So yeah, actually, instead of leaving it with the -17/6, and I'm glad you asked that question. Thank you. Let's go ahead and flip it back over to a mixed. So 6 goes into 17 twice. And so 2 times 6 is 12. So that takes care of 12 of the 17, leaving behind 5, 6. And this is a good example of when I say, when you start doing so much work, it's very easy to lose the signage. It's a good idea to flip back and go, I had a positive times a negative. Make sure you tack on that negative sign before you circle your answer. Okay. Good question. Thank you. All right, so speaking of mixed, let's look at, well, and you guys don't even have to put this one in your notes if you don't want to. What's anything times 0? These are the only ones where you don't have to show any work because I don't care if you flip it, turn it upside down, inside out. It doesn't matter. 0 times whatever you flip this to be, it doesn't matter. It's still going to be 0. Okay. All right, so what if we have one like, let's do number 13 here. Number 13 here. So the rules from last week still apply, which is we can't do anything with mixed numbers, okay? So we have to flip them or we have to convert them into impropers. And then we also will have to flip that 4 and 1 6 or 1 6. So first let's convert everything to impropers, okay? So we've got 18 times 3, which is 50, what is it, 54? And then plus 1 is 55 over 3. Okay, so there's that one written as a improper. So I know my first number is going to be 55 over 3. And then if I convert the second term, I get 6 times 4 is 24, plus 1 is 25 over 6, and it's negative. So now, okay, I've got them both written as impropers. Now I'm ready to write my multiplication problem, which means the 55 over 3 stays, right? This was division. I write it as a multiplication by flipping and putting that -6 on top, or the 6 on top. Doesn't matter where you put the negative. Now that we've converted everything to improper, we've gotten the reciprocal of that second term. We've got it set up now as a multiplication problem. Now we're ready to work it. We can cross reduce, right? 3 and -6, they're both divisible by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. And I'm going to put that negative up there so I don't forget it. Going the other way, 55 and 25, because they end in a 5, I know they're both divisible by 5, so I'll start there. 55 divided by 5 is 11. 25 divided by 5 is 5. So that's reduced as that can get. Now that I'm all the way reduced, I'm going to go ahead and multiply across the top. 11 times -2 is -22. 1 times 5 is 5. And then the last step is going ahead and changing it to a mix. And I'm going to put that negative there so I don't forget it. 5 goes into 22 4 whole times, right? 4 times 5 is 20. That leaves me a remainder of 2 over 5. And so my final answer, and again, just take a hot second just to go back and say a positive times a negative should give me that negative. Yes.
If you forget to reduce one of them and do it the harder way, would it still, and you still get the right answer?
Yeah, so if you forget, you talking about if you forget to cross reduce at the beginning?
Yeah.
Okay, so let's take that as an example. So if we just multiply 55 times 6, so without the reducing, if we just multiply right here, 55 times -6, we get -330. Okay. If we don't reduce across the bottom, we have 3 times 25, which is 75. So you would get this. Okay. Now, when you go to change this to a mixed, if you will in your calculator take 330 divided by 75, you get a whole number of 4. And with bigger numbers, it kind of makes it easier to do that. Remember this I showed you yesterday or on Friday. 75 goes into 334 whole times. Okay. 4 times 75, we're doing long division here. 75 times 4 equals 300. You have 30 left over. Okay. So your remainder is 30 over your original denominator, which is 75. Now you got to look at 30 and 75, right? They both end in a 0 or a 5. So we know they're at least reducible by 5. They might be reducible by more, but we'll start there because that's the easy one to see. So your whole number stays your whole number. If you reduce 30 by 5, you get 6. And if you reduce 75 by 5, you get 15. And then what you have to recognize is that they're also now it's reducible again, right? And if you recognized from the get-go that they both were reducible by something higher, sometimes you don't have to do it in multiple steps. But when you're dealing with bigger numbers, sometimes it's easier to take it in chunks. Now, these are both divisible by 3. So again, your whole number stays your whole number, but you can reduce 6/15. They're both divisible by 3, so you get 2/5. So you'll notice, don't forget to tack on your negative. You do get the same answer. You just find yourself dealing with much bigger numbers. So sometimes, like this time, it made for more work because you had a bigger fraction. So changing it to a mix maybe wasn't as easy. And then once you got it in mixed, you had to do a couple of reductions to get it down to that final answer. But yes, in answer to your question, if you don't reduce first, you still will get the right answer. It just sometimes makes it a little harder because you're dealing with bigger numbers rather than smaller ones. But you're still going to get the right answer. All right, are we good there? Any questions? You can't do anything with mixed numbers at the beginning. You always have to convert those to impropers. And then when you're dealing with division, you always got to flip that second term and turn it into a multiplication. Okay. Now let's do an example where we're dealing with variables just because we want to make sure that we're comfortable with that. Let's do number 20 here. So write that example down in your notes. And you don't do it any differently as far as the process. You keep the same, right? AB over 8 stays the same. Turn it into a multiplication problem. Flip the second fraction. So now my A is on top and my B is on bottom. So I've inverted it, or I've taken the reciprocal of that second term. Now I'm ready to cross reduce. 8 and A can't do anything with each other. Going the other way, the B and the B, okay, they do reduce. So across the top, notice I have 2 A's. I'm not going to be picky here about how you want to write it. So it's A times A, right? A times A across the top, or just AA. And across the bottom, it's 8. The more cleaned up way to write this, okay, If you have a, yep, if you have a times a, it's the same as a squared, because squared just means something times itself, over 8. I will take either one of those answers, okay? I'm not going to be too picky here, but it's kind of good to start getting used to seeing things like this. Okay. I think let's do just number 25, last one. You don't even have to put it in your notes if you just maybe want to watch one through, okay? So we've got negative 2x over y. That's our first term. We're going to change it to a multiplication, which we're going to put the y on top and the 4 on bottom. Reduce the 2 and the 4 to negative 1 and 2. Reduce the y and the y to 1 and 1. So across the top, what do you have left? You have a negative 1, a positive 1, and a positive x. Know that the negative 1, right, is going to make that top a negative value. You've got a negative times a positive, so you are going to have a negative answer. So you can write negative x or negative 1x, doesn't matter. And then across the bottom, you have just simply 1 times 2, so over 2. And that would be your final answer. And remember I said with anything that has a variable in it, don't change it back to a mixed. Okay, so if you end up with, and I don't know that any of these do, so I'm just going to kind of write you an example out here to the side. If you end up with an answer of 6a over 5b, okay, don't change 6/5 into 1 1/5. Because you don't know what the value of a and b is, you have no idea how to multiply and how those affect anything. So if it has a variable, leave it just like this. Okay, if it does not have a variable and it's improper at the very end, go ahead and change it back to a mixed. Good? All right, I will hand out your paper. You've got the rest of the period. I would utilize your time in class to get those Khan Academies done. If you didn't, okay, technically, right, it's Monday, but I'm kind of giving everybody just this last few minutes to clear up anything that hasn't been cleared up. Your homework is due tomorrow at the very beginning of class. So if you have your Khan Academies done, you'll probably be able to get your homework done in class and you can go home with no homework. If you don't have your Khan Academies done, get them done in class and then do your homework this evening, okay? For those of you at home, go ahead and click load in Kami and then show all your work and email me if you have any questions.